The new and delete operators are used to allocate memory space for objects in C++. Here I have a working copy of newDelete.cpp from Chapter 4 of the exercise files. Until now, we've been using dynamically allocated objects, but this is not always what you need. Sometimes you need to create an object and use it beyond the lifetime of the function or block that it's created in and destroy it later. This is what new and delete are for. So just a brief demonstration of new and delete. I have a little contrived object here with 3 data members and a constructor with an optional, because it has a default value, that makes it an optional parameter. And I have a destructor and 3 little getters for A, B, and C. And our constructor is defined down here. See, it has a little message that says the constructor has been called, and it initializes our A, B, and C to the value that's passed, +1 and +2. And our destructor also has a little message so we can see what's happening. I have a message that we're about to construct the object and a message after the object has been deleted. So here I allocate space for the object using the new operator, and here's how that works. I declare a pointer of the class that I'm creating an object for. I use the new operator and the name of the class, and the new operator returns a pointer to the new object. New will allocate space and create the object and call the constructor, and then return a pointer to that new object in the allocated space. The delete operator does the opposite. It calls the destructor on the object, and then it reclaims the space so that the object can no longer be used. And its space is reclaimed and returned to the pool of space. So when I build and run here, you see we have our message that we're about to construct the object. The constructor is called. We have our report of the values, 1, 2, and 3. And then the destructor is called, and then we have this message that the object has been deleted. So we can see that the destructor is being called before we get to the end of the block. And that's what it is that we want in this case. So it's really simple to use. It's actually very simple to use. Before new and delete, we used to have to call a function called malloc that would create the space, and another function called free to free the space, and it didn't call the constructors, and it was all very complicated. But this is simple and easy to do, and is considered best practice for allocating space in static memory for objects. Now, there's an important option here that you need to know about. We'll cover exceptions later in this chapter, but if you're not using exceptions for error reporting, then you need to use the no-throw option, like that, with new. Otherwise, when or if new fails, it will throw an exception. With the no-throw option, instead, it'll return a null pointer, and we can test for the null pointer like this. And so that's all very clean and easy. And the delete works just like normal. And so when I build and run, you see everything still works as it did before. We can also, of course, pass values to our constructor like this. And so now when I build and run, I should get 5, 6, and 7 down there, and I do. Or you can allocate space for an array of objects. Now I'm allocating space for 3A objects. And if you do that, then you need to use a corresponding version of delete, and that would be with the square brackets after the keyword delete. It's important that these match. If you're allocating an array of objects, then you need to use the array version of delete. And if you're not allocating an array of objects, then you need to use the not array version of delete. So now when I build and run, you'll see we get 3 constructors and 3 destructors because we're constructing 3 objects and destroying 3 objects. So the new operator is used for allocating space for objects in C++. It's very simple to use. Every object allocated with new must be destroyed with delete. Otherwise, your program will leak memory.